you could use it was Pascal's triangle where you find to be different factors at first.
You can also just use your calculator.
Yeah. Um, which I'm looking for currently. Uh-huh. So you just do NCR of that number, right?
Yep.
Option calculate. No. NCR, okay. And 8 plus 20 x. How do you put x in the bracket?
So you can't into the calculator. So what you put is like 3C0, 8 to the 3, and then 20x to the 0, and you just put everything into the calculator without the x.
Okay. So 3, yeah. It's a bit of a reminder. Yeah, okay. It's coming to me. And then the next one is 3 choose 1.
Yep.
8 squared, then 20x to the 1.
Yep.
And then 3 choose 2. 8 to the 1, 20x to the 2. And then the last one is 3 choose 3. 8 to the 0, 20x to the 3.
Yes. X to the 3. And so let's do the x to the let's do the x to the 2 one. What do you get for that?
So 3 choose 2. 8 to the 1. 20 to the 2, which is 9,600.
So that is 9,600. And so, and what about the x?
The x,
Mm-hmm.
is it just multiplied in? Or x squared, x squared?
Yeah. And so, because that can't be put into your calculator, you just have to put it in yourself. So that bit you do, so you do it for all of them, and that's what you get.
For the 3 choose 1, 3 choose 2, all of that, you could use Pascal's triangle, right? Instead of, finding all of them separately.
You could. Would you prefer? Don't use Pascal's triangle. What if it was to the 7 or something? Okay, this one. Factorize fully, then fully. Sorry, factorize each bracket. What do you get? No, just factorize the first bracket.
So that is 4, 8, 4.
Mm-hmm.
Then 2 plus 5x.
Yeah. 2 plus 5x. And if you did that 3 times, because there's 3 brackets, how could you then fully factorize it?
Could you do bracket 4, bracket 2 plus 5x, close the brackets, cubed?
Yes, and you could also do 4 cubed, 2 plus 5x cubed.
Yeah.
And what that shows you is that you can, if you've got a coefficient, you would cube that as well. And that's the case in general. So then, this one. Oops, 1 second. Let's make that blue. How would you do this? Do you know?
So use a decimal value of following decimal places. 45x over 4. I'm not too sure what's going
on. You may not know. So if you compare the two brackets, what do you notice?
That they're both to the power of 10.
Yeah. And so what do you know about what's inside the two brackets?
That they multiply up to the same thing. Or they are the same thing?
They are the same thing. So basically 1 plus x over 2 is equal to 1.0005. Sorry, 1.005.
And not to the power of 10.
Well, yeah, it's like you could do the 10th root to both sides. And so you would simplify it. And so solve for x. You can put that in your calculator.
I get 0.01.
Great. X equals 0.01. And so what I did was, so a minute ago we expanded this cubed thing. So this one up to the power of 10. I expanded the first 4 terms for part A. Part B says use these first 4 terms in the above expansion to estimate the value of this. Any idea how you do that?
Yeah. You find the common multiplying factor?
Nope. X is 0.01.
So you put it into the original equation?
Which one?
1 plus x over 2
and
to the power of 10.
You would get 1.005
to the 10. So then you just expand that bracket.
I did that.
I am not too sure then.
You put it into this one. X is 0.01.
Why only those 4?
Do it and I'll tell you.
Okay. Is it because it becomes significantly smaller, so it doesn't make a difference?
Boom.
15, 0, 1. So 1.1625.
1625. They want 5 decimal places?
1.16251.
That's it. And 1.05114. Did you put it in correctly?
It's the x being cubed, right?
Yeah.
Oh, I forgot the squares on one of them.
Okay.
Yeah, 1.05114.
Ah, okay. So it's not that. So that's it. So that's it. 1.05114. Let's see. So this one, I found the x to the 5 term. It is 126 x to the 5 sub 0.001 or whatever it was into this
one. And I get 1.26 times 10 to the minus 8.
So that is 1, 2, 3, 4, 5, 6, 7, 8. And 126, was it?
126, yeah.
So it's to the minus 8, so there's 8 zeros to the left. And we were asked for the previous one to 5 decimal places. 1, 2, 3, 4, 5. And that's why we didn't need to do that any further, because it wouldn't affect the 5th decimal place.
I see.
for the x to the 4 term, or sorry, we did it to the x to the 3 term, that would affect it to the 5th decimal place. And that's why.
Okay. How do you know which term will affect it?
They will. So the way it will look like in an exam question is they will say expand this to the first, let's say, 4 terms, and then they will say use your expansion to get it to 5 decimal places. And so you will never accidentally. You could check if you wanted to, like check an extra term, but it is a part B type of question. So part A, expand the first 4 terms, and then part B, use your expansion to estimate this value.
Okay.
Yeah. Okay, how about this?
What values does the sequence converge to when x is 0.01? So you just substitute in those values, right? For x. So do 0.01 plus, is it plus? Yeah. 0.01 squared plus. Yeah. Do you add them together, or do you just find them by themselves and see?
No, just like what number did it get closer and closer to?
Okay. So for the third one, it's 0.01 recurring. For the fourth one, yeah, it's the same thing, so it's 0.01 recurring.
Okay, so I'm going to do this. And this is from 1 to 10. So what's going to... okay, so what number is getting closer and closer to?
0.01. It kind of stays the same after a while.
Is it not going like to the minus? Like what is 0.01 to the power of 10 or something?
To the power of 10?
Yeah.
1 times 10 to the minus 20.
And so what number is that very close to?
0?
Yes. So that's converging on 0. Okay. How about...
Is that true to all values less than 1?
Okay, now sub in minus 3.
Okay.
Because minus 3 is less than
1. Minus plus minus 3 squared. Minus 39. This one will become exponentially larger. Well, not exponentially. Yeah, it just grows to infinity.
And what did you do that to the power of?
To minus infinity. I did that to the power of 10, and it becomes a large number.
That's it. And if we take a look at the results, so the first one we said it converges on 0. The second one also converges on 0. The minus 0 point.
So would you say that?
However, the when x is 2, that diverges towards infinity. And when x is minus 3, it oscillates between positive and negative infinity. So when it's an even number, it's infinity. When it's a negative number, it's negative infinity.
Yeah.
And so that's what those two look like there. So basically what that shows...
I need to remember to put it in brackets, yeah.
So what this shows you is that between 1 and minus 1, it converges on 0.
Yeah.
And that's true for both of them. Between 1 and minus 1, it converges on 0. Yep. Sure, I could do that. Yes, so if you... I could show it. Let's not. With the other binomial expansion, there's... the binomial expansion formula is derived a certain way, and if you derive it a different way, you get this separate formula for the binomial expansion. So instead of it being the 3 brackets, you get this. And last I checked,
we've done a bit of work with it, yeah.
And last I checked, they give that to you. Okay, any idea what this is about?
Show that 2x less than 1 is equal to x is less than a half. Do you just equate or rearrange the equation? So you just divide both sides by 2?
So you can use what's up here.
So you say that minus 1 is less than 2x, which is less than 1.
Yes, and then you divide by 2. And so what do you get there?
So you get minus a half that's less than x, which is less than a half.
And therefore the magnitude of x is?
I'm not too sure how to express it. We haven't been taught this.
Less than a half. So
Okay.
it's between negative a half and plus a half. So if the magnitude of something is 3, it could go all the way to 3, or it could be minus 3, because the absolute value of minus 3 is 3, that type of thing. Okay, let's try these. So we did A, let's try B.
Show that a third x less than 1 is equal to x less than 3. So you write minus 1 is less than a third x, which is less than 1. And that becomes, you multiply it by 3. So minus 3 is less than x, which is less than 3. So magnitude of x is less than 3.
Great. I'm happy. Okay. This time, find the binomial expansion of this. 1 plus 3x squared, and I rewrote it as 1 plus 3x to the minus 2. And this is using the other formula.
So minus 2 is equal to n, and x is, well, it's 2x, or 3x even. So you do 1 plus minus 2 times 3x plus minus 2 times minus 2 minus 1 over 2 times 1 plus minus 2 minus 1 times minus 2 over 3 times 2 times 1. Oh, and the first one was multiplied by 3x squared. And the second one was multiplied by 3x cubed.
Yeah. And so what do you get there?
I need to write that. So you get 1 minus 6x plus 6 over 2 9x squared minus 6 minus 2 4, so minus 24 over 6 9x cubed 27x cubed.
For the second one, is it? Oh, the third one, is it? 27x cubed?
Yeah.
What was the second
one? 6 over 2 9x cubed 9x squared.
What is 6 over 2 9?
That is 3. Yeah.
Gregoire.
3 times 9, which is 18x squared.
Gregoire. Just, if anything was for the calculator, this is it. So, minus 2. So, same as before. You can't put in the x, but you can put in every other number.
Okay.
2. Where is factorial?
So 27.
Yes.
Squared.
Where is the factorial button? Or you have a calculator, graphical one, do you?
I've got a slightly different one, yeah.
Alright.
It's in probability.
Okay.
I don't know.
I'll find it in a minute. Yeah, so it turns out they were both 27, oddly enough.
The next one isn't 27 then.
Because
I think I've done.
The cubed one wasn't?
Yeah.
How long was the cubed one?
Minus 108.
Right, x cubed.
X cubed, yeah.
Yes, there we go. Oh, I wrote squared. Should be cubed. Minus 108 x cubed. Great. State the set of values of x for which the expansion is valid.
State the values of x. So do we add all of these values together?
Can't.
To make.
Can't.
I know we can't. What I remember doing was I was multiplying stuff, but then was excluding the x cubed multiplied by x squared, for example, because that would make x to the 5. But I don't know if that's something else.
That's something else.
Okay.
This here, so ax, so this form of binomial expansion holds for all negative and fractional values of n, provided that ax is between 1 and minus 1.
Okay.
Or the magnitude of ax is less than 1. And so, for what values is this valid?
So it's valid for all the values of ax being in between minus 1 and 1.
Yeah. What is ax?
Ax is 3x.
Yep. So minus 1. So 3x is between minus 1 and 1.
Yep.
So how about for values for x?
Values for x. I can't remember what it said on the other side. I didn't see.
Basically turn 3x into x.
Oh, so you just change that. So it's x is in between minus a third and a third.
Yeah. And how do you put that into the magnitude?
So you do the abstract thingy.
Absolute?
Absolute x is less than a third.
Is less than 1/3. That's it. So basically, so our expansion is true for values of x between a third and minus a third. Basically, the absolute value is less than a third. Yes, that's it. Okay. How about this?
Expand. I suppose it's a magnitude. Okay, so we used to say concept 1 minus 2x to the half, where a half is n and ax is equal to minus 2x. So 1 plus half times minus 2x plus half times half minus 1 over 2 times 1 minus 2x squared plus half minus 1 half minus 2 over 3 times 2 times 1 times minus 2x cubed. And then solve that. So I get 1 minus x squared plus minus 0.5x cubed.
X cubed. Take a look. Yep. Okay. And then show that you can use the expansion to find the approximate value for this. Square root of 0.94.
0.94.
Or for what values of x is it
I remember doing this. For what values of x is
this expansion valid?
It would be up until the squares, so x squared, right?
No.
Then I don't know.
For our previous one, it was the magnitude of x is less than a third. So for what values of x is this expansion valid?
So for this one, the expansion is valid. Minus 1 is less than minus 2x, which is less than 1. So then it's minus half. So it's 0.5. It's less than minus x, which is less than minus a half, I think.
Okay.
Done something wrong. Does that make sense?
Yep. And so the magnitude of x?
It switches. Yeah.
Yeah, the signs flip and I just flipped it.
Yeah. So magnitude of x is less than a half.
So the magnitude of x is less than a half. Show that you can use the expansion to find an approximate value for this. Okay, how can we find an approximate expansion for a square root of 0.94?
I can't remember how to do it exactly.
There's a little trick to it. So this was 1 minus 2x to the half. And the square root is the same as to the power of a half. So that's 0.94 to the half.
Yeah. So that's our ax value.
Well, we just did 1 minus 2x to the half.
Yeah.
And we want 0.94 to the half.
Mm.
So what would we do?
Will we put it in to this 0.94 for x? For ax?
Well, 1 minus 2x is equal to 0.94.
Oh, so you do 1 plus. Oh,
so this is what we did. This is what we did here when we had to find 1.005 to the 10. And we expanded 1 plus x over 2 to the 10.
So we do 1 minus 2x to the half equals 0.95 to the half?
Yes, 0.94.
Okay. Mm-hmm.
And solve.
What does the binomial, what does this actually do, or what's it prove?
It's a fast way of expanding brackets. So we just expanded this, and now technically we could keep expanding this forever, and so we just have to stop it at some point.
Yeah. Okay.
And so what do you get for that? 1 minus 2x
to the half. You can eliminate the halves from both sides.
Yep. Or you can just solve it in the calculator. I know which one I prefer.
So I get 0.03, which is x.
Okay, x equals 0.03. And what's next?
Show that you can use this expansion to find the approximate value for that. How do we know that this method is correct? Or do we just have to assume that it is?
I'll show you in a sec. What do you do next?
Hence find 0.94, correct 2 decimal places. So we put x in the binomial. And do we just do it until the third term that we found?
Yep.
So we do 1 minus 0.03 minus 0.03 squared minus 0.5 times 0.03 cubed. And I get 0.969085.
And so to 2 decimal places?
So 0.97.
So 0.97. Okay, put into your calculator square root of 0.94.
And I get 0.967. Yeah, so pretty close.
Yes, and so it's an approximation of doing the square root. And so that's 0.97 to 2 decimal places. And so that's how you can check your answer. And that's part of, that's I suppose an application of this. So you can, it's a way you can square root something, I suppose. Or get an approximation of it. So if you did something to the power of a half, that's the same as square root. You then, figure out, okay, x would have to be 0.03 for it to end up with 0.94 in this case, and then you sub that in for x, and that's your approximation.
Okay.
Okay. Any questions about that?
No. I get it.
Okay, let me just see this one. So this is to the -1, and it's going to be very similar. And so I'm just going to skip that one. So then we can do those questions. Okay, so these are the exam questions. Is there any there that looks like it's worth doing?
Maybe maybe A.
I agree. There's a little trick to it.
Okay. So 2 plus 3x minus 3.
Sorry. I'll run this formula.
X is less than 2 over 3. Okay, so 1 plus minus 3 times
Slow
3.
down, slow down, slow down. I did that thing at the start for a reason. I remember it now. This formula is for 1 plus ax to the n. Is our bracket 1 plus ax to the n?
No, it's 2 plus x to the n.
And so, how do you get it?
2 plus 3x.
How do you get it so it's 1 plus?
So you multiply the bracket.
What would you get?
So you get 2 plus 6 x to the minus 3.
No, you factorize out 2.
Okay. So 2 bracket 1 plus a half x to the minus 3.
1 plus what, sorry?
1 plus 3 over 2 x to the minus 3.
Yes, very close. And you know the way you factorize out the 2?
Yeah.
It is, you factorize out 2 to the minus 3.
2 to the minus.
So remember earlier when we factorized out the 4, because we had to factorize it out 3 times, it became 4 cubed. And this is the same thing.
So it's the same here.
So you could factorize it out like within a bracket, like the whole thing to the minus 3, and it becomes 2 to the minus 3. Yes, we can now use our formula.
Okay. So here, what do we do with the 2?
The 2 to the minus 3?
Is it just a multiplying factor?
Yeah. Correct. And so basically at the very end, we have to remember to multiply everything by 2 to the minus 3.
Okay.
And if it helps, put into your calculator 2 to the minus 3.
Which is 0.125.
Yeah. Yeah, or 1 over 8 or whatever. And so it's just multiply everything by 0.125 at the very end.
Okay. So we start with 1 plus minus 3 times 3 over 2x.
Yes. So n is minus 3. And a is 3 over 2.
Cute. Okay. 1 plus. What's the point of having learnt the other way of binomial expansion if we're just going to use this in the exam?
So the other method is for like whole numbers. It's a very quick, easy way to do to expand like to a cubed bracket or a quartic bracket, power 5 bracket. This is good for negative or fractional brackets, but this is limited. Like x here, x has to be between plus and minus 2/3. Whereas for another one, it just it's always true.
Okay. So, yeah, I've come to a kind of final sort of thing.
Okay.
So 1 minus 4.5x plus 54x squared minus 135x to the 3.
135x, was it?
Yeah, x cubed.
Okay, is that it?
No. There's only power of x, including the term x3. So that's what they've asked for, and then we need to multiply everything by 0.125.
Yes.
Okay. And do you leave it in that form, or do you multiply everything individually?
That's a good point. Yeah, let's leave it. Okay, so this chap expanded it 1/8, but I don't have the official mark scheme. But yeah, you could just go from there. Let's see. Let's do this one. How would you start this one?
Okay. 6 over root 9 minus 4x. So that becomes 6, 9 minus 4x to the half, minus a half. And then we factorize out the 9. So it's 6 times 9, so 54, 1 minus 4 over 9, x.
Something's missing.
And it's 54 to the minus a half.
No. Oh, go on, put into your calculator 54 to the minus a half.
0.136, very small number.
Okay. And now put into your calculator 6 times 9 to the minus a half.
A different number. So it's the 9 only.
Yes, Bidmus.
That needs to be.
Yeah.
Yeah.
And that's quite a difficult example. Great. I'm happy with that. And then you would just do it from there as normal.
Yeah.
So any questions there?
Not in particular, no.
Okay. What is this thing? This is binomial expansion for partial fractions. Not really the same thing. Let me just go back. What's the 3C and 3D? Because there was one extra little thing you were talking about, like find the term x cubed and all that. This is it. This is it. Yeah. How do we do this? Oops.
So we raise 1 plus 3x. 1 plus x cubed, which becomes 1 plus x minus 3. And here we have 2 brackets. So do we multiply them, or?
So it's similarly to the previous one. Instead of it being at the very end 0.125 times everything, it will be this 1 plus 3x times everything. and so you have to just expand the second bracket that has the negative one as normal and go from there.
Yeah. Okay. So you go ahead with n equals -3.
Yeah.
And ax is equal to just x.
Yep.
And massa, okay, so 1 plus -3 plus -3 -3 minus 1, 2 times 1 plus -3 -3 minus 1 -3 minus 2. Oh, and that's x squared. I forgot about that. X cubed. 3 times 2 times 1. Yep. 3. Okay, so in the end I get 1 minus 3x plus 6x squared minus 10x cubed. And then all of that is multiplied by 1 plus 3x. And do I need to multiply everything?
Mm-hmm.
Oh yeah, I do.
Tell me when you have an answer to that.
So you multiply everything apart from the 3x and the minus 10x cubed?
Yep.
So then you get 1 minus 3x plus 6x squared minus 10x cubed plus 3x minus 9x squared plus 18x cubed.
Okay.
So you get 1 minus 3x squared.
Sorry, you just cut out for a second there. Yeah, but I'm confident that you'll be okay. Yes, and so you did the right thing. So what if they said... What if they said just find the coefficient of the x cubed term? Can you hear me?
Can you hear me?
Yeah, you're back. Yes. So what would you do if they asked you just find the coefficient of the x cubed term? I can hear you. Can you hear me?
Yep, I can hear you now.
What would you do if they asked you for the coefficient of the x cubed term?
Then I'd say 8.
Yes, and so what you could do is you could do that from the beginning, and so you could just do the expansion up to the x cubed, and then just when you're multiplying by 1 plus 3x, you might not have to multiply out everything. Only the bits.
So I just multiply the -3, -3, -1, -3, -2.
Yes.
Yeah.
Yes, and that might be a way to save yourself some time. I think you were good for that. Let's see. So you can use it for partial fractions as well. Let's just take a look at this partial fractions thing. That's the one thing. So this is partial fractions expansion as for an x cubed. Yeah, have you done partial fractions yet?
No, but I feel that we'll be covering it soon.
Okay, so you use it in partial fractions as well. So basically, partial fractions is before you added together two fractions. In partial fractions, they give you the answer, and you have to figure out what two fractions were added to give you that answer. And this one will be a times 3x to the -1. And the other one will be whatever number b is times 1 plus 2x to the -1. So you use it for partial fractions as well.
Right.
Let's just take a quick look. But let's see. So binomial expansion, yes. So old formula, you can do it using this method. And what we saw was when you factorize out something, you keep the power. So remember that because the it has to be in terms of 1 plus ax for the new formula. Where did the x equals 0.01 come from for this one?
So that came from equating the 1 plus x over 2 to the 10 and equating it to the 1.005, and that's what x became.
Yes, and so you can use this expansion to estimate values.
So if they said, okay, we've got 1.005 to the 10. Okay, so in this question, essentially what they're asking you is to expand the brackets of that 1.005 to the 10, but only to the 4 terms, and then add them up.
Well, those 4 terms you are you can't add them because they're different x terms. But when you put them into when you sub in 0.01, you don't have to expand, like you don't have to put that into your calculator 4 different times. So all you have to do is put in 0.01 instead of x, and then next thing you put in is the final solution. You don't need to actually show what each individual one of those is.
Okay.
And what you'll get is a number that is roughly approximate to 1.005 to the power of 10. How do we show for what values the expansion is valid?
We find the modulus function of x.
Yes, and that's because if x was 2 or something, then the more you expand it, it would get very close to infinity. Like basically, to the power of 3, to the power of 4, to the power of 5, it's going to get a huge number. Or if it was a negative one, it would go to negative infinity. And
could you remind me again, what happens once we've found the boundary?
You're just so. So this we did this one here. So what do you mean by once we found the boundary?
So once we found this, so say look at C is modulus x is less than 3. How does that affect the equation?
So we did one where it was the square root of 0.94.
Yeah.
0.94 is between 1 and -1, let's say. That shows that it's valid for that number. However, if it had been like the square root of 2, it could be invalid because that's outside of the range of valid. So
of the equation of the binomial expansion.
Yeah.
Okay.
Yeah, and so that's just a way of validating it. So that's just a small point. I mean, they're not going to give you a number that's invalid, you know.
Yeah.
So it'll be like, it might be a little one marker type of thing. So we did that. Yes, you have to make sure you put it to the power of it. Yes, this was 6 times 9 to the -1/2. So just watch out for the Bidmus thing. Just watch out for that. And that was a particularly tricky one, but that's why I put it in.
Okay.
That was that. And then, yes. So, yeah, I think you're pretty good for that up to x cubed, and then you can save yourself some time. So this one wanted it up to x cubed, but if sometimes they just want the coefficient of the x cubed term, and so you might be able to save yourself some time by thinking it out a little bit.
Okay.
How was that for you, Gregoire?
That was good, thank you. Also, but I'd like to say that I got my report back and I had exceeding the target that I was given.
Well done.
And that, well, thank you to you actually, because one of my teachers is completely redundant in teaching.
Oh no.
So, yeah, so I'd like to just say thank you for helping support me on that side of the course.
Oh, you're very welcome, Gregoire. And yeah, no, that's great to hear. And yeah, you're doing the hard work. That's the main thing.
Thank you.
Anything in particular that you want to go through next time? Do you know?
Next time I'll be very close to a test on differentiation and vectors. So this week we'll be doing vectors, and then I have a test on that chapter. So I'll probably revise that, and I may ask for another lesson, maybe on Saturday or Sunday, if there's time.
Okay. So differentiation of vectors, something like that?
Yeah, they're both in the same chapter.
Okay.
So yeah.
All right. Any questions for me in general?
No, that's great. Thank you very much.
All right. Well done, Gregoire. You did great. I look forward to talking to you again next week.
Thank you.
All right. Have a good week. Goodbye.
You too. Bye.